Hello, my name is Edison. Welcome to another STM32 tutorial, and today I'll be showing you how to display some text using the OLED display, as you can see from the video section, and how I'm going to connect this OLED to my nuclear board. Is through the I2C communication protocol. We have two lines, the serial clock and the serial data. So for the SEL, will be connected to PB8, and SDA will be connected to PB9, which corresponds to I2C1 in STM32. So, and again, obviously you have to connect the VCC and ground. So let's go to our STM32 Cube IDE and develop our project. So we're going to click on new STM32 project, and we're going to select the board that we are using. In my case, I'm using Nucleo F446RE, and then I'll call my project Oled STM32. Then you can initialize in your default mode. So the first thing that I'm going to do is clear all the pinouts. And again, as mentioned, we are going to use I2C1 peripheral. So we go to connectivity, then I2C1, then I2C1, and you can see these are mapped to PB7 and PB6. So we are going to shift these to PB8 and PB9 by clicking on the PB9 pin and just click SDA, and then I2C SEL, and then go to system call. We're going to enable our RCC clocks, that is for the external oscillator, and then we have we go to clock, then select the HRC, and then we can run it to maximum frequency, and yep, there we are. So let's maybe something else about the I2C. We need to select the fast mode. I'm going to use this in fast mode, that is 400 kilohertz. So then click the tool code generation, and one thing I'm going to do, I'm going to add the library files for the OLED display. So go to where the files are, and I'm going to highlight all these, then right click, copy, and then come back to my project. I just paste them there, and then let's go to our user code begin includes. So I'm going to include stdio.h, and then I'll have hash include string.h, and then hash include fonts.h, hash include ssd1306.h. so let's build the code and see whether we have any errors. So far so good. So maybe you can have a look at the header for the OLED, and you can see that this is the address. So the address is 3C, but have to be shifted to the left by 1. So the result is 078, and then you can see that we have the width and the height. So if you're using the smaller OLED display, which is 128 by 32, just need to change 64 to 32. So again, we have two colors here. So for this, let me name this blue, because it will appear like it's blue. So, and then we have these functions to initialize the OLED display. Then we have the function to update the screen. Then we have the field. So in the field, the color is either black or blue. And then you have a function to draw a pixel, and then you have function to write a character, a string. You set the cursor based on the position of where you want to start writing your characters, and then you can invert colors. Then we have these function to write that help us to write commands to the OLED display. So maybe you can look at the initialization function, and you can see that we are sending several commands to the OLED display so that we can initialize the LCD. So this is the command to turn off the display. We have 20, that is 20H. You set the memory addressing mode. So all these commands you can look at them later. So, and this function returns a 0, returns a 1 when it's not successful, and returns a 0 when initialization is successful. So I'm going to initialize this into my main. So we're going to have user code begin to, and let's initialize this. So this takes a parameter of the handle type, def of the I2C peripheral, and we are using I2C1. And maybe we can test this. If that is not equals to 0, then we can call the error handler. So yep, so after initialization we're going to delay for some seconds, so we can have maybe 2 seconds, and just try out the LCD. So we are going to fill the display using a blow. So let's have this. So SSD fill, we have this function to fill, and we have blow, and then SSD we have to update the screen. So yep, so let's build this code. We have an error. Where is it? SSD 130C. So yep, let's have blue. Let's build again. So no errors. So let's load the code to a board. Click OK. Yep, and you can see that our OLED is on and it's up and running. So now we're going to display some text. So we're going to use SSD 13 write maybe string. So the string you're going to write is ask Edison, and the font we have 3 fonts. These you can choose. This is the smallest one, the medium is this, and then you have the biggest. So I'm going to choose the medium font, and the color, let me have blue. Yep, we can have black, and then these we can change these to, okay, we can change this to black and change this to blue. And then maybe just to format, let's have the cursor. We can begin at 0, 0 position. So remember you have 0 to 128 in length, and the width we have 0 to 63. So you can have 0, 0, and now we can have the farthest pixel being at 127 by 63. So in this case we are going to start at 0, 0, and let's print that. And again we are going to have maybe position 0, 20, and let's see what we have. So in this case let me have is this better, 20, 0. So these, let me just check at these function. You see that we have x and y. So x, y. So X, okay, better. So let's run this code and see what we have. So ask Edison, do it. Let's view these and let's load the code to our board. Yeah, you can see what happened. So I'm going to have this 0 and these at 20. Let's view the code again and load the code to our board. So I want to have it in 2 separate lines. Yep, there we are. So you can shift all the characters to the right by setting the offset. So maybe something else that I would like to show you, you can print changing numbers. Maybe let me just create a variable here. I just create int n equals 0, and let's have a character name. It's a buffer. We can take around 40 characters, and in the while loop I'm going to write something here. So SSD, let's have fill these with black, and then I'm going to use sprintf to cast to num, and what I'm going to cast is %d or num or counter. Let's have the word counter, counter is equals to %d, and then we have n, and then again we are going to print this. I'm going to write this string, going to write num font. Let's have the medium font, and for the color let's have blue, and again I want to set the position of the cursor. So set cursor, and maybe I can have it at position 30. And then finally, after doing that, we are going to update the screen. So let's update the screen, I2C1, and maybe we can print these after 1 second. So delay 1 second, and maybe let's now increment n. Yeah, sure. So let's build the code and allow the code to our board and see what we have. So we pushed it so far, so we can have 10, maybe 10, and also let's add some delay here so that you can be able to visualize the ask Edison do it. So let's have 5 seconds, and then yep, let's build the code and run. So we can say that we have the ask Edison, and then we have our counter incrementing 5, 6, 7. So something interesting about this library is that you can create your own patterns by writing to a specific pixel. So what I'm just going to do here, let me clear these out, and let's have our cursor starting at 0 0, and I'm going to draw a horizontal line over the first line. So let me have a for loop for int n equals 0, n is less than 128, then n plus plus, and then we are going to draw pixel. So SSD draw pixel at position, the first one is x, so we are going to have it in the first line, but this we are going to use n. So for the color, let's have blue. So maybe after doing that, we can update the screen, and let's have a delay of maybe 1 second. So let's view these and run the code. So expect a line. Oh, this is stretching downwards. So let's have n at position 0, and then let's view the code. So you can see the line is now horizontal. So again, you can draw another horizontal line at the bottom. We can have 63, and then let's view the code. So this is now 0 to 63, but horizontal is from 0 to 127. So let's view the code and see whether you have a line at the top and also a line at the bottom. Yeah, you can see that we have two lines. So if you want like another line on the left, drop down, so it's from 0 to 63. So in this case this will be 0 and this will be n, and then let's have so this will be 127. So let's see. So run the code to a board. Yep. So using this draw pixel, you can have your own logos, your own patterns. So maybe something that I really don't want you to forget. We can have SSD, write string, and place subscribe, just to make sure this fits. So I'm going to use the smallest font, and I'm going to have these in blue, and maybe I can use another one at 20, share, or like, and yep. So let's see what we have. Let's load the code to a board.